Welcome to another quick learning movie. My name is Jan Huyink, and in this movie I again would show you our TOPTriac. TOPTriac means temperature and overload protected triac. It is a triac that will protect itself when the junction temperature exceeds 125 degrees Celsius. This is our second movie on TOPTriac. In the first movie I already explained why we designed this part, for which market segments it is intended, and what the basic operation modes are. In this second, more technical movie, we want to show oscilloscope pictures and explain more about the demo board. Here we have our system of today, the TOPTriac demo board with a TOPTriac inserted. The TOPTriac has no heat sink, so it will heat up rather quickly, and in this way we can more easily show the functioning of the part. We have a load, a 1.2 kilowatt hairdryer, a 4-channel oscilloscope with 2 current probes and 2 voltage probes, and an isolation transformer that is mandatory to use for safety, but also because we do voltage measurements, and the voltage probes will actually connect the ground of the oscilloscope to the common of the board. So that's why we need to have this board floating. Therefore we need an isolation transformer. I will now switch on the board and it will start up in phase control mode, and we will then have a look at oscilloscope pictures. So we hear the hairdryer switching on. This is a 1.2 kilowatt load, and here we see the oscilloscope pictures. In white we see the gate trigger current. We don't see all the gate trigger pulses because the oscilloscope is set to show a 50 Hz signal, and the sampling rate of the scope is too slow to catch every single gate pulse. This is why we see them every now and then, but not all of them. In orange we see the gate voltage. In blue we see the blocking voltage of the TOPTriac, and in green we see the load current. I can now increase the power, and you can see that the load current will become a sine wave. Now we have full power, and the TOPTriac is heating up very quickly now. It will soon reach or even exceed the maximum junction temperature, and now it's switched off. Actually, this switching off happens inside the TOPTriac. It is not the application that does it. The triac switches itself off, protecting itself and protecting the load. I can now reset the TOPTriac and make everything functional again. I do this with the manual reset button. And again, we have the power. I can minimize and maximize the power. And again, the TOPTriac tripped. Now we will have a look at continuous conduction mode using DC gate trigger. Okay, we powered up the board again, and the board will actually default to phase control minimum power setting. I now want to show DC gate triggering for continuous conduction. I will press a switch and we will have DC current into the gate, and you will hear maximum power. You can see the load current, a sine wave. No more gate trigger pulses because there's DC current into the gates. We wait until the TOPTriac trips, which happens now. Junction temperature exceeded 125 degrees Celsius, and it cools down now. And I can give a manual reset to make everything functional again. So I do this now. And again we have full conduction of the application. And again the TOPTriac tripped. So it's very clear that the TOPTriac protects itself and the load. We have 2 settings for the board. We can do phase control and continuous conduction. And I hope you liked this movie on the TOPTriac demo board and the oscilloscope waveforms. Thank you very much and be back soon.